All right, so geometric series. So following up the sequences with this series, so it's the same kind of idea as with the arithmetic. So the sum of the terms is a series. So here we go. Here's the sequence 2, 4, 8, 16, and so on. And so first term in the series, S1 is 2. The next one, 2 plus the 4 gives us 6. 6 plus the 8 gives us the 14. Plus the 16 gives us 30. Plus the 32 is 62, and so on. So there's our sequence and our series. So series when we add up the terms. All right, so this one down here is S5. 62 is S5 because it's the sum of the first 5 terms. When you add all of those 5 terms together, you get 62. All right, so in your textbook, they derive this formula in your textbook, and again, you can have a look if you really want to on page 133. I'm happy to talk through that with you if you really need to know how they get the formula. Now, there is another version of it. Here it is. So, because the ratio could be bigger than 1 or it could be less than 1. Or, as I said here, in between -1 and 1. So, a fraction. All right. And you can use this version of it, the formula. It's not essential to use this version. You still get the same answer, whichever version you want to use, but I'll just point that out because it's in your textbook. All right, so I'll probably just use this first version up here all the time. Probably won't bother with the other one. All right, all it means is that you don't get negatives in the question, but to the final answer it makes no difference because the negatives cancel. All right, anyway, I'll stop rabbiting on about that. So here's an example. Find the sum of the first 9 terms of this sequence. All right, so A is the third, of course. The ratio, again, if you're not sure what the ratio is, take a couple of terms. Say the second term, I'll go term 2 divided by term 1, which is 1/9 divided by 1/3, which fractions turn upside down and multiply. So the ratio is 1/3. All right, we're asked for the first 9, so that's n equals 9. And so we use Sn equals R, R to the n minus 1 over R minus 1. All right, so in this case, S9 is R, the ratio, 1/3, 1/3 to the power of 9 minus 1 over 1/3 minus 1. All right, that's a calculator job on that one. So let's grab our calculator. Let's have a look at it. Oh, I can't quite get that out of the way. Oh well, not to worry. All right, so what is it? It's a fraction. There it is, that fraction there. So I'll use my fraction template. Then I've got another fraction. All right, got another fraction. There it is. I'll leave it up there. So then I've got another fraction, 1/3. So let's put 1/3, 1/3, then times by this bracket. Then I've got another fraction, 1/3 to the power of. So we make sure we go out here to the power of. So you notice how the cursor's now gone big. To the power of 9. Oops, 9, not 6. Get it right. Then I need to turn the cursor big again because that's going to be power otherwise. So cross there. No. Take one. Hopefully this is going to be right. Close my bracket. Over another fraction. -1. And have it in standard. If I've got it in standard, there it is. Gives it to me as a fraction. And if I, instead of having that in standard, had it in decimal, give it to me in a decimal form. All right. Okay. So the thing I was concerned about here was this, but because I don't have the bracket around the 9 minus 1 in brackets, it's interpreting it correctly as 1/3 to the power of 9, then take 1. Even though it kind of looks a little bit messy, whereas up here in this question I did in the previous, no, I haven't even got it there now. Yeah, haven't even got it, so I don't know what I'm waffling on about here. All right, so to be guided by the question, always give it as a fraction unless you're told otherwise, would be my rule of thumb there. All right, so I need to drag that down so that I can, oh, wrong up, there it is, minimise that. And so that answer was 9841 over 19683. All right, so the next one, for the geometric sections 139, find how many terms must be added to get a sum of. So Sn is 1093, n is what we're after, a is 1, looks like we're multiplying by 3, and so Sn equals a r to the n minus 1 over r minus 1. So 1093 equals 1 bracket 3 to the n minus 1 over 3 minus 1. And again, I'd be using a calculator job here to solve this. So use the solve function in your calculator. So here we go. Solve function. We're solving 1093 equals fraction 1 times the bracket, which has a fraction in it. No, 3 to the power of, again, we're going to use, you can use n if you go in here, but x is on the keypad. 3 to the power of x, take 1, close that bracket. 3 minus 1, all the way there. Solve for x for me, please. And there we go. X equals 7. So the answer to this question is that n equals 7. Right, you could go a bit more by hand if you wanted to, but in the end you're probably going to have to use your calculator anyway. So you might as well just, solve this rather than doing some algebraic thing and then using your calculator. All right, so that's it for geometric series. So as always, have fun, and if you need help, get back to me.